Alright, welcome back to our Breakout labs. This will be Breakout 9. This lab is going to focus on structures and enumerators. We're going to start with a new project, and if you didn't save your last Breakout 8 as your template, it's okay. You can just copy your code from Breakout 9 or from Breakout 8 into this one. So I'm going to start from the Breakout template, and I don't believe I did save 8 as a template. I would definitely suggest at the end of 9 to save it as a template. I'll try to remember to do that as part of the video to demonstrate again how to do that. Okay, so it should be launched, and if we look in here, it should be Breakout 7 because I didn't save the Breakout 8 code in it. So that's not a big deal. We can do that very easily. We just go out and find Breakout 8 in my documents, repos, Breakout 8. And in here, I'm just going to open these two files in a text editor like Notepad++. And then I've got a couple other things open in my notepad. So here I'm just going to copy, this should have been Breakout 8. I'm going to copy, I'm just going to do Control-A to select everything, Control-C to copy. This is the header. So I'll come here, Control-A to select, and Control-V to paste. And then I'm going to go ahead before I forget and change this to Lab 9 and save. And then back here in Notepad, in the CPP file, Control-A to copy, or to select, Control-C to copy. And then in here, Control-A to select, and Control-V to paste. And then let me change this to 9 before I forget. Alright, and then now I can close these. Alright, and so now I have the code from Breakout 8 in here, and we can start moving on with Breakout 9. Alright, we're going to start with, let's go over to the header file, and in here we define these properties of the ball. And back here in our implementation file, we populated these properties for a ball. So we're going to create a structure to represent the ball. And mainly it's so that we don't have to pass all these properties around as parameters. So in our header file, up here by the properties, we are now going to define a structure. So we use the keyword struct, and since it's a user-defined data type, we're going to use a capital letter for the first letter. So we clearly identify that this is a user-defined data type that we're creating. And so what we need is we need the X position and the Y position and the velocity X. Oops, that needs to be a float. And the velocity. And let's do an integer for the radius. I don't think we'll ever do a floating point radius. All right. Now notice we don't assign any values to these because these are parameters and they're meant to change throughout the program, and so it's kind of bad practice to assign initial values here. But the radius is not going to change. It's going to be ball size, so we can go ahead and set that now. Ball size. And that way, anytime we create a new variable of type ball, its radius would already be initialized to ball size, but we would need to initialize these other values. All right. So we don't really need to document this too well because it's pretty spelled out for this program what we're talking about here. All right, but now we have the structure for the ball, or a data type of type ball that has an X position, a Y position, a velocity X, a velocity Y, and a radius. So now we can come back over to our implementation file, and here where we assign these, instead of these, we can create a variable for this. We're just going to do a new, and then we'll remove those ones above, but we're going to create the ball, and it's going to be of type ball, and we can just call it ball, and we can assign it. Okay, so remember, if we look back here, it goes x position, y position, velocity x, velocity y, and radius. And we know that the first 32 bytes, or however big a float is, but let's assume it's 4 bytes, not 32 bytes, sorry, 32 bits. The first 4 bytes will be for x position, the next 4 bytes for y, the next 4 for velocity, and the next 4 for velocity y, velocity x, and velocity y, and then the next 4, because then are 4 bytes for radius. So we don't necessarily need to know that. We can use C++ list initialization to initialize this. We could say 0, and the compiler would assign a 0 to that whole memory block, however large a ball type is, which would be 1, 2, 3, 4, 5 times 4, 20 bytes. And we don't have to be exact, this is just for discussion, right? But we actually can assign the first 4 bytes, we could assign this. And to be correct, we should have done, because it's a floating point, so we should do a float literal there. We can then use a comma to say, for the next block, assign this value. And this way we don't have to know that the first one was 4 bytes and the next one was 4 bytes. We just need to provide it with a value of the correct type, or that can be converted to a float. All right, so then the next was the velocity x, and we just want to assign 0.0 and 0.0 for the velocity y, because we don't want the ball to go anywhere. And then we don't need to specify radius because we're already providing that value here in the header file. All right, so we can say that, and then we can get rid of these. Now this is going to cause some errors, and that's fine, because we're going to get, see, we have some red show up, and that's good. That's going to tell us where we need to replace some things, all right, because we were passing those as arguments, and now all of a sudden they're not there anymore. But that's okay, we can fix those. But that it helps identify where are we going to need to make changes, okay? So we just took ball x, ball y, ball velocity x, and ball velocity y, and replaced them with ball of type ball, or structure ball, which means we can update these functions now, that instead of accepting all these arguments or parameters, we can now just pass it a ball. Now notice these were passed by update because they could be modified. Well, we need to do the same thing with our structure. If we need properties of the structure to be updatable in this procedure, we have to pass the structure parameter by reference. So we're going to replace all 4 of these with a ball data type that we're going to pass by reference, and we'll just call it ball. Now down here, same thing, except for we don't want to pass it by reference, so we'll just pass ball. All right. Oop, I shouldn't have capitalized that completely, just the first letter. All right, now we're going to have some errors, other errors show up. One, we still have these errors down here. I'm not going to fix those yet. I'm going to come down and fix this. So we've changed all of this structure, so we need to fix our function. So one of the things is we got rid of all these parameters. All right, and one thing is we didn't handle our lag parameter in our documentation, and we should have. So let's do that now. First of all, we're going to pass a ball, and this will, well, its name is ball. And it's going to represent the location and speed of the ball. And then our lag, this is going to be current frame time plus lag. Remember, we build up in our delta time, we build up until we at least equal 1 full frame. Then we do an update. But that delta may have some extra in it, and so it's really our full frame time plus possibly some extra lag. Okay, so now we're going to replace this with what we put up in the function declaration. So once again, it's a ball type passed by reference, and we called it ball. Now we're going to get some more errors. Now notice I'm still not going to fix them yet. All right, let's come down here to render, and same thing, only we're not going to pass it by reference. It's going to be a ball type called ball. All right, now we've got this collision checking, and we'll handle that in a minute, but let's fix all of these errors that we've got right now. Luckily, we can do all this at one time, and this is very typical in programming. We have a bunch of places where we used ball X, and now ball X is going to represent the X position in our ball structure. And our local variable is called ball, and that's what we called it in the parameters as well. So they're all the same name. So what we need to do is everywhere where we see this, so I'm going to hit Control H, and I'm going to say everywhere, oops, I didn't mean to do that. Let me do it again. Control H, and everywhere where we see ball X, we want to replace it with ball dot X position. Now I could double check myself before I do this. I could say, well, I want this to be ball dot, and notice it gives me the pick list, so I can say X position. So remember, we use dot notation with structures. All right. Why is it saying, why has it got an error there? Oh, right. Sorry. I forgot. In here, we actually need to get rid of all these because, sorry, I was thinking of inside the function we need to fix them. We said we were just going to pass the whole ball variable, so this ball variable. So we actually want to replace all of this in the function call with ball. So we're passing the whole structure as the argument. So same thing down here, we're passing the entire structure variable as an argument. Now we can do what I was about to do down here. So now we have ball X, ball Y, and these ball velocities. All right, so we can fix all these at one time. Okay, so one is we have those errors here. We also have those errors in here, and we have those errors down here. So we can fix all this with some find and replace. So everywhere where we see ball velocity Y, we want this to be ball dot velocity Y. So, I am going to copy this, and I'm going to do Control H on that. And everywhere where I see that, I want to replace it with that. Now I want to get rid of this one because I don't want it to replace that twice. But all the rest of them, in the current document, everywhere where it sees ball velocity Y, I want it to replace it with ball dot velocity Y. So I'm going to hit replace all. Okay, and it did 5 of them. Right now, I don't need to change very much. If I just come in here and do an X, and say replace that with ball velocity X, and hit replace all, and it did 6 of those. All right, now everywhere where it sees ball X, so if I get rid of velocity in this, then that was called, and I'm pretty confident in this, that it was called ball.x position. And I can do replace all. It did 9, and here, everywhere where it says ball Y, I want it to be ball dot y position. Oops, dot y position, and replace all. And this should work in the other development environments like Sea Lion. All right, and I'm going to hit save. And look, all of our errors went away. Now right now, notice we're passing all of those individually, and we'll talk about our collision checking in a second, but we want to change as few things as possible. So right now, all we did is everywhere where we referenced ball velocity x or ball x or ball y, we've changed those to the structure variables now. So nothing's changed in here. We're going to come back and change this in a minute, but let's just trace through our changes. So for our update and render function declarations, we put in our ball structure. And then in our main, we declared a variable of that ball structure and initialized it using our list initialization. And then in our call to update, we now call it passing the ball structure. It's passed by reference, so it should be passing the address of the ball variable. In the render, it's passed by value, so it should copy the whole current ball structure to this ball parameter. Then in our update, we're now receiving that ball parameter by reference, and we're using the dot notation to access its y velocities, its x velocities, its x position, and y position. Right? And then in our render, we're passing the ball, and we're using that to access its properties. All right, so that should have handled that. Let's see if it builds. All right. So one thing, I want to go ahead while I'm here and update these comments. In our update, we've got the ball, location, speed of the ball, and lag. I'm going to copy those from the update where I did that, and I'm going to put them down here in the render method. All right, so we have the ball, location, speed of the ball. The lag now, lag for the render is not current frame time because we build up lag until we reach a current frame time, and then we must have some additional lag. So this is actually the build up of lag between frames. So we're rendering a lot more times than we're updating, so we're actually getting partial lags for each render. All right, let me try to run this, and we shouldn't see anything change so far. All right, there goes our ball. Yep, and we're still getting our deflections through our collision checking. All right. All right, I'm going to stop the debugger. And if we look now, the only thing is we got all this handling of the walls. And we've got them here, we've got them down here in the render. If we go back here to the header file, we put a lot of effort into defining all the walls, and in the end it kind of just looks like a big old mess. And we're going to have to, if we look at our implementation, when we do a collision checking, we're really talking about a circle versus a rectangle. But for the purposes of this program, it's really the ball versus a block, either a block wall or one of the blocks that we want to break. So we're going to try to simplify some of having all these different parameters. So let's look at back here in this header where we're defining all the wall information and coming up with the sizing. Let's go ahead and define a new structure. And first structure is going to be a block. And notice we capitalized for the data type to represent a user-defined data type. And this one, I'm going to say that this is going to represent the breakout blocks and walls. All right, and so this is one block, and one block, now these are don't move, so they don't need floating point numbers. They can just be integers, but they need an X position, a Y position, a width, and a height. All right, and then we are going to have 4 border walls. So we're going to create another structure to represent the walls. And so we'll create another structure, and we'll call it walls. And let's say border walls. Scroll down. And we are basically going to have 4 blocks. So we're going to use this block structure data type that we created, and we'll have a top wall, and a bottom wall, and a left wall, and a right wall. Now the walls would never change, so I could initialize them here, but just for illustrative purposes, I'm going to come back here because we're going to look at how does it work with structures of structures. So I'm going to come here to the implementation file, and up at the top in main where we start to create our game objects like the ball, let's create the walls here. And I'm going to do it first here, border walls, and we're going to create a variable of type walls, and we'll call it walls. All right, now notice I'm not even going to initialize this variable. So let's actually start initializing the walls by using the dot notation to say the top wall is going to equal, and then we'll use our list notation. And so once again, if we look at it, and I think if we hover over it, yeah, it's not going to be able to break it out for us to see. So we'd have to look in here to see that it goes X, Y, width, height. So if we just look at how we defined them here, we basically need to copy these values into the initialization. So we can just copy or fill in the values here, like the second property was going to be this for the top wall. So when I'm over here, the first was the X, that was 0, the Y was that. If I go back in and just keep switching, that was window width. And then wall size. And if you just format however you want, if you're in Visual Studio and you do the semicolon, notice it's going to format it for you. All right, so I'm going to copy this. I need 3 more of them. And I'm just going to change this to bottom. And if I get the period and replace it with a period, then it'll give me the pick list. So left and right. And now I just have to fill in the values. Now watch what I can do. I can grab the header, drag it down, and hover over. So I'm holding the left button on my mouse down and drag it over this picture and drop. And now I've got these side by side, and that'll help me do this. So I'm doing the bottom wall, so it's going to be 0, 0. And then ball width, or bottom width, it was going to be window width. Right, window width, and then wall size. So that's correct. So then the left was going to be 0, 0. And it was going to be wall size. And then window height. And then the right wall was going to be window width minus wall size. And then it was going to be 0. And then wall size. And then window height. And if I don't want to mess with this, I get rid of that, hit the semicolon, let Windows format it for me. So what we did was we created a variable of type walls, which declared and said we're going to need however many bytes that was, 20 bytes. And then we said in the first 4 bytes, set these value properties. And then, or actually, I'm sorry, this was more than 20 bytes because it was, if one of these was 20 bytes, this was 4 times 20, so 80 bytes. So this declared 80 bytes, and then in the first 20 bytes, we put these 4 values, and then in the next 20 bytes, we put these 4 values, right? Now, we could have done, and just to illustrate real fast, we could have done all of this in one initialization. If we had done this, we can say, well, the first block of walls, this top, is going to be this. And then we can do a comma. I'm going to come down, and we could say, well, the next block was going to be this. And then we could do a comma, and then the next block was going to be this. And I would probably tab that in and then do a comma. And then the next block would be this. And we could have initialized walls like this and say that was equal to this. And so what we've done is we've got a list, and then we have 4 lists inside of that to represent the structure inside a structure. But this is really difficult to read. This is a lot easier to read and to mess with later if something's wrong. So I'm not going to do that, but I just wanted to illustrate that we can initialize lists inside of a list. So let's start with our render method and say, well, here in render, and actually to help us find what all we need to change, let's get rid of all of these constants. Now we need to keep wall size, but we don't need any of these other ones. So let me put that back. I just got rid of all of the top wall, bottom wall, left and right. I kept wall size in our header file. And I'm going to save, and now over here in the implementation file, we'll get a bunch of red. And that's good. That's going to tell us where we need to fix things. So here in our update method, where we're calling collision checks, and down here in our render where we're drawing. All right, so what we need to do, because we define these as a variable inside of main, we now need to pass this variable. So we need to pass it to both update and render. So we can just put it in here. It doesn't need to be updated. We're never going to make changes to the walls. So let's do walls. So data type walls, parameter name walls. Let's put that in there. It's passed by value. And then same thing with our render method. We want to pass to it the walls so they can be rendered. All right, and now we need to go fix the update and render method. So let's start here in the update. After the wall, we're going to pass walls, lowercase, the parameter name is walls, and this is going to be the border walls. for collision checks. And we're going to put that right in here. Of type walls, parameter name walls. I'm just going to leave that for now, and I'll come down here to the render method. And let me copy that comment from update. Why retype something if you've already got it? Come down to render. And here in render, I'm going to place that here. And then here in the function definition, we're going to have the parameter walls. All right, so now here's how we're going to do this. Our draw quad, we can't make changes to it. It requires the 4 properties spelled out. So here's where we need to start replacing this. This is going to be, now watch what I'm going to do. I'm going to get rid of these other 3, and I'm just going to fix this one. So this would be the walls.top.x position. And this y will be the walls.top.y position. And this will be the walls.top.width. And then the height will be walls.top.height. Alright, so now that I've got that one fixed, I can copy it and paste it 3 more times. And now I'm going to select that row, so I just put my cursor here, hold shift and down arrow, and it selects that whole row. Or I could hold shift and hit my N key and select just that row that way. And now I'm going to do my Control H, and everywhere where I see top, I want to replace it with bottom. Now, it did away with my selection, so I'm going to come back and select it again so I can change this to selection. So it's just in this one row. So you can see the 4 replacements I'm going to get. So I'm going to do top to bottom, replace all. I got my 4. I'm going to leave that there, but I'm going to move my selection down here. So shift end, and I'm going to replace top with left, replace all, and then I'm going to come down here and hold shift and hit end and replace top with right and replace all and save. All right, so that handles, we can draw the 4 walls that way. Now, if we scroll back up here, we've got this error here, right? So we need to do something similar to our collision checks, but we're going to do more to that. Let's scroll back up here and see what these are. So in our call to update and render, we now need to pass walls because we defined them up here as having those parameters right after the ball. So we're going to need to pass the walls to update. Walls, and remember they're defined right here in our main, and then in render we need to pass walls. Alright, so before we go fixing all of these, let's go ahead and make it so that we can just pass the whole structure or pass a whole wall to collision check, or better yet, instead of a wall, we want to pass a single block, because we'll want to do collision checks for a wall and we'll want to do collision checks for the actual blocks that we want to break. So we want our collision check to actually take the ball and a block. Alright, so let's come up to our function definition up here, and let's say that collision check is now going to take a ball, and it doesn't update it, so we don't need to pass it by reference, and it's going to take a block. And that should give us everything that we need. Now it's gone green here because there's no definition to match this declaration, but we're going to fix that. We're going to come down to its definition, down here, There's render, here's collision check. Okay, so we're no longer passing all this. We're going to get rid of that, and we're going to say we're going to pass a ball, the location and size of the ball, because we don't care about speed when it comes to collision checks, just its location and size, and a block, the location and size of block to check. Okay, and then we are going to come in here, and now this is now, and I'm just going to select them all. We have a ball, called ball, and a block, and we'll just call it block. All right, now all these things go red, which is good. That gives us everything we need to fix. So what we can do is we can select, I'm going to select all of the text down to, should be just down to here. I'm going to highlight all that text. And that's just so I don't end up replacing something up above or below that I didn't want to. And I'm going to hit Control H. And I'm going to say anywhere where you see CX, that's the circle, or in this case, the ball, right? And that's now going to be ball.x position. And let's just see the ones that it highlighted. It looks correct. And I'm in selection, and I'm going to hit replace all. Okay, now here we got CY, so if it sees CY, that's going to be ball dot Y position. And in selection, replace all 4 of those. Now if it's only 1 or 2, it's faster sometimes just to type it. All right, so anywhere it sees RX, that's now going to be the block X position. So block dot X position. All right, anywhere it sees RY, that would be block dot Y position. And replace all. All right, now what do we have left? We have an RW, and we have an RH, and a CR. But there's only one of each of them, so let's just work those out. So RW, what is it not liking here? I don't know. Let's fix these first and see what happens. RW is the block dot width. All right. RH was the block or the rectangle dot height. And here it was block dot height. Oh, and here was an RW. Block dot width. And then down here, this was the radius of the ball. So this is going to be our block dot radius. Oops. Oh, not block, I'm sorry. Ball dot radius. All right, and these are much better than those 2-letter abbreviations, but I told you we'd be replacing those soon anyway. Okay, so look, now all we passed a collision check is the ball and the block we wanted to check. All right, so let's come back up here to this red here, and here's what we need to replace. Collision check now. We just passed the ball, and I just selected and deleted all that. We're going to pass the ball, and we're going to pass, in this case, one of the blocks. So in this case, top. Walls dot top. Because remember, walls is defined as type wall, and top is a block. So walls are parameter walls, which is of type walls, and its top attribute, which is a block. So we're going to pass the ball, which is a ball structure type up here, and a block, which in this case was going to be the top block here. So we just need to do that in these. So I'm going to copy these two, and then I'm going to replace all of this. So, all right, let me give myself some more real estate over here. All right, so Shift End, and then I'm using the arrow key to come back, and that'll be, and I'm going to replace the top in each one of these. All right, so we have top, this will be bottom, this will be left. And remember, if you're not sure, just get rid of the period and redo the period, and then you can pick. All right. So that should be everything. Let me do a build. All right, we got lots of warnings, conversions between floats and ints and floats and doubles. That's fine. Everything succeeded. If I run, everything should still be working. So we don't see anything different yet. Yep, so we're getting good collision checks off the walls. Just using the arrow keys to speed it up and change its direction. Okay. We're next going to introduce our first enumerators. We're going to start with our collision checks here. So our constant values here are good, but the fact that they're simple integers also lend us to using something called an enumerator. And so we're going to use an enum, or for enumerator. And like a data type, we capitalize its name, and we'll call this a collision type. So I'm using the camel case, but with a starting capital. And similar to a structure, we're going to use the curly braces to define its body. And its body is pretty much going to be these labels. So I'm going to do collision none, and then I use a comma and say collision vertical, and then a comma and collision horizontal, right? And then I'm going to use these comments here just to keep that. And this was 1, and this was 1, 0 in binary. And now I'm going to get rid of these constants. All right. And what we learn in the lecture is that, and from our book, is that the first element in an enumerator, enumerators are all of type integer, and the first one is automatically assigned value 0. The second one would be 1, whatever the value of the previous one is, plus 1. And on down the line, unless we use an equal sign. If I was to do an equal to, then this first one would be 2, this would be 1 plus that, so we see 3 here. And this would be 1 plus the previous one. If I was to do equals 4, then this first one would be worth 2, this one would be worth 4, this one would be worth 5. So without anything, it defaults the first one to 0, and all the others default to 1 plus that. So it just works out for us okay that it's 1, 0, 1, and 2. All right, now not much needs to change here. I'm going to copy this new type, and we're going to say that our collision check function is now going to return a collision type instead of an integer. And we're going to come down to our collision check function, and we're going to say, well, this is going to return a collision type, which is the same description, and we're going to replace this here to say this is going to return a collision type. All right, now this is our return variable, so it also needs to be of that type. And notice we were already setting it to a constant, and all we've done is move that constant into this enum. And so it recognizes that that's a collision type, collision none. And down here, it's going to recognize that these are now collision type, collision vertical, and collision type, collision horizontal. And here we're returning quadrant. Now down back here, it's okay. This returns a collision type, but we know that these are integer. Enums are integers, so we're going to leave this as an integer because the concept of doing an or equals on an enum does not exist. But it is legal with an integer to do or. Remember, we were trying to combine these bits together to get however many of the bits might have been set by a collision, by multiple collision checks. In case the ball was hitting both the top and the left wall at the same time, we could end up with both a vertical and a horizontal collision, which was legal and was perfectly fine. But to do this or equals, this should stay an integer type, but that's okay because we can return an enum into an integer since enums really are integers. So the rest of this code works fine and there's nothing else to change. And if I build, everything should still be working the same. Make sure our collisions still work. All right, so everything appears to be working fine. All right, so one last enumerator. Let's add a new enumerator, and this one I'm gonna put it above this one because it's prominently more important and comes up sooner in the program. We're gonna create a new enum and we're gonna call it directions or direction. And it's gonna have a direction of none. And it's going to have a direction of up, down, left, and right. All right, so based off this logic, none would be 0, which is good because we can always test for none or 0 as a Boolean expression. And then up should be 1, down 2, left 3, and right 4. All right, and this is our new type called direction. All right, so we are going to focus on this section here. And we're going to actually do, here we had our process input, our update, and our render, right? But we're going to move this process input into its own function now. Now we're going to start by creating 2 new variables up here. So up here with our ball, before we start our timing, we're going to create some direction. Now later these are going to represent the paddle, but for right now, that's okay. We're going to represent the ball. And so we are going to have directions. We are going to have a direction type, and we're going to have a current direction, and we're going to set that equal to none. And I want to do, that's okay, I think we can leave it. I hate these constants are a little too close to other things that we might have, so let's specify these with an abbreviation in front of them. Direction none, direction left, and direction right. right? And then over here, then we'll say this is going to be direction, none. And then I'm just going to do a comma here and say next direction. And it's going to equal direction, none. All right, because our ball's not currently moving in any direction. All right, so now when we come down here, we want to create a process input function. So I'm going to come up here, and process input comes first, and it's going to return a direction. And it's going to be called process input. And we're not going to pass it anything. And now we need to come down and define the function. So right here after main, before update, we're going to have this new function called, that's going to get user keyboard input. Oh, you know what? We need one more. Matter of fact, we're going to do, I meant to do it this way. We want to know if we got direction exit. And we are going to set that equal to -1. So we're going to do that first, because if we add 1 to -1, we get 0, and our direction none is 0 again. So that's good. So now we are going to come in here and get user input, and we have no parameters. And then it's going to return a direction, which is going to be the next direction to move and remove, and we'll say default is direction none. All right, so now we have our direction data type, and this is process input, and it didn't have any parameters. We do in the body, and we have a direction variable, and we'll just call this direction, and we'll go and initialize it to direction none, and we'll return direction. So what we're going to do is I am going to copy this case statement. I'm not going to cut it. I'm just going to copy it for now. I'm going to select the whole thing and copy it, and I'm going to paste it up here. All right. And what we want to know is we need from main, I'm going to copy this statement here, and I'm going to put that inside this function. And I didn't cut it because I want to remember where it was, so I know where to go back and put things. So I'm going to do this, and this is going to be get keyboard input, and then I'm going to switch on this key, and if it's W, I'm going to set direction, my local return variable, I'm going to set that equal to direction up. All right, now I'm going to do something similar for these others. So I'm just going to replace all of them real quick. And here, I'm going to set this one to direction exit. All right, and then if I come up here, I just need to say this is going to be direction down. It is going to be direction left, and this will be direction right. All right, and no break on the last, and no default, because I'm handling that with the initialization here. All right, so now I can come up here, and in main, where I do this here, I want to set the next direction here the next direction is going to be equal to process input. All right, so here we see key has been highlighted as red, and that's because we no longer have that here in the main loop. So our update method must change somehow. So if we look up here, right now our update method, we're passing a character direction, but now we actually want to pass a direction enum data type. So this is going to be a direction, and we can just call it direction. Right, and we're going to have to make some more changes as we start to implement the paddle. Like for right now, we're not so much going to be using current direction, but let's, you know what, we can, no, we're not going to use it right now, so let's not worry about it. We'll mess with that later. We'll leave it here, but right now we're only going to be dealing with next direction. So, but let's go ahead and call this next direction. Or we can just get fancy and call it next. We know what it means for the update. It's the next direction. And so here we're going to pass our local next direction to it. All right, and then we now need to implement that in our update method. So here direction is now going to be next, and this will be the next direction to move the ball. All right, so first of all, if next direction happens to be exit, then we can we could set that now, or we could do that here in our main loop. When we check it here, we could check for setting next direction to game over here. But either way, it doesn't really matter, so long as somewhere we set that if next direction is exit, we want game over to be true. Well, let's just do it here in the update. So we can just check here if and we called it, oh, I forgot we have to change this. We call this next. This is now a direction data type, or enum, called next. And we can say if next equals direction exit, then we just want to return from here. We don't need to do anything else. So we can just return true, which is user wants to exit. All right. Otherwise, we're still going to do this switch statement. All right. And you know what? Let's not do it. We already had it handled in here, so let's just handle it in there for now. I'm going to get rid of this. I'm sorry. We can just handle it here in the case statement. And so we're going to switch on next. And now this is now going to be, instead of W, it's going to be direction up. And this will now be direction down. And notice we can even get rid of these comments now, because now our enums spell it out. So this will be direction left, and this will be direction right, direction right, and then this here would be direction exit. Okay, and that should do it for that. And so we have our new process up. Let's put our end here, end process input. So we have our new process input function. We're calling process input here and getting the next direction and passing that into update. And we have set that up here. All right, so here's one of the things we can do is, well, no, this is good. Let's leave it. We'll add more as we get to the next part of the, because we're gonna have to make changes to some of this. What did I do wrong? Identifier not found, process input. I must have spelled it differently. Process, oh, I got too many S's. Right, no. Oh, I got too many C's. Process input. All right, let's build now. All right, there we go. Let's make sure everything's still working. All right, so everything's still working. Okay, so that's going to be it for Lab 9. So we introduced enumerators. Oops, didn't mean to collapse it. We introduced some enumerators, and we introduced some structures, and we saw how those allowed us to greatly reduce the number of parameters that we're passing around now, and also allows us to better spell out in code what we're doing. In other words, it helps to self-document our code well. All right, so that was it. Still haven't seen anything new, but in the next lab we're going to introduce the breakout blocks that we can then have the ball start breaking. All right, so hopefully you're enjoying this so far. Oh, before I go, I said I would go through again. Let's go ahead and save this as our new template in Visual Studio. So here I would do export a template, project template for Breakout from Project Breakout 9, and our template name is just going to be Breakout, and our template description is Breakout video game, something like that. We want it to go into this zip file in my exported templates, automatically imported into Visual Studio, display an error. Okay, so hit finish. It should say it already exists. Do I want to delete it and create the new one? Yes. Okay, and now it's there. So now next time I start a new project, all of this code will be my template. Now, if you're using Sea Lion or something like that on the Linux or the Windows, then all you need to do is just copy these two files to wherever you're saving your template ones and overwrite those, and then use those the next time you start a new project as your template files. All right.